Welcome back. This is video 10.2, mole mass and mole volume relationships. We're converting the mass of a substance to the number of moles of a substance and the number of moles of a substance to mass. We're also calculating the volume of a quantity of gas at STP. We've been doing these things. Avogadro's hypothesis is a vocabulary term, standard temperature and pressure, and molar volume. Here's four key equations. Those are all good to know. Let's do the completion. At STP, 1 mole of any gas occupies a volume of, this is the one you should be familiar with, yes? Let me get back to a 22.4 liters is already there. 22.4 liters. This quantity is known as the molar volume of the gas. To determine the volume in liters of 2.00 moles of SO2 gas at STP, you would use, all right, so we've got moles and we want liters. To determine the volume in liters, we got moles, we want liters. We got moles, we want liters. Volume of gas is moles times 22.4. 22.4 liters per mole. Sorry, that was my alarm telling me it's almost time to go home. Number 4. Okay, so number 3. To determine the volume of in liters of 2 moles of SO2 gas at STP, you would use 22.4 liters per mole as a conversion factor. Blank expressed in grams per liter, I believe that's density. In grams per liter is used as a conversion factor when converting from volume to molar mass. When converting between numbers of represented particles, masses, and volumes, you must always convert to moles as an intermediate step. Now, third period, I think it was yesterday, we saw in the blue packet, there is a mole roadmap. That's what we call it. It's got a bunch of circles with moles in the middle, and it tells you how to get from one place to another. So you might want to yank that out whenever you're working on some of these problems, see if that makes sense to you. If not, we can talk about it on Friday. I'm turning the page. True, false. Classify each of these statements. As always, true, sometimes true, never true. 1 mole of any gas occupies a volume of 22.4 liters. That's sometimes true if we're at STP, which it didn't say that in the problem, so we just have to say sometimes. 7, for a substance of known molar mass, the number of moles of a sample can be calculated from the mass of the sample. If we know the molar mass, we can get the moles if we know the mass. That's always true. The volume occupied by 1 mole of a gas is dependent on the molar mass of the gas. That is never true. Something on my screen, sorry. And number 9, the volume of a gas at STP can be calculated from the number of molecules of the gas. Well, that'd be the hard way, but that is always true. All right, here we go. Matching. I believe 22.4 liters of a gas at STP. Anyone? I believe that's molar volume. Standard pressure. Anyone? Oh, I'm sorry, B, 101.3 kPa, 1 atmosphere. That's standard pressure. 0 degrees Celsius. That sounds like a temperature to me. Could that be the standard temperature? And mass in grams of 1 mole. That's molar mass, which leaves only E for number 14. And again, mole roadmap in the blue packet. It's a lovely document. You'll really enjoy using that. Okay, so part D problems. What is the density of N2O gas at STP? Well, we can find the molar mass. And we know that 22.4 number, which is liters per mole. So we want to do the inverse of that. 1 mole over 22.4 liters. So once you get the molar mass, we'll divide it by 22.4, and that will be the density, right? Moles are canceling. Grams per liter, that's density. So you could do that. What's the mass of 2 moles of NaCl? Well, once you find the molar mass, That's for 1 mole, right? We'll multiply by 2. How many moles are in 16 grams of O2? Well, again, we need the molar mass, but we're going to use 16 grams and divide that by the molar mass, right? And that will be the number of moles. And then the volume of 16 grams of O2. So we're going to have to turn our grams to moles. And then we'll take our moles times 22.4. Your mole roadmap could help you on that. You're starting with grams down at the bottom. You go to moles in the middle, then you go up to the left to liters. And you'll be able to figure that out. So work on those 4 problems and have those ready to turn in. Again, if you want to watch video 3 first and then do those, you may do that. See you in a little bit.